Welcome to today's lesson. Today we are going to look at multiplying fractions. Before we look at multiplying fractions, we first need to understand what we mean by the word reciprocal, so we're going to fill in our Freyer diagram. The definition of a reciprocal is a number and its reciprocal have a product of 1. A reminder that product means the result of multiplying two things together. So if we multiply a number and its reciprocal, we should get the answer of 1. The characteristics of a reciprocal is if you flip a fraction over, you get its reciprocal. And if you do 1 divided by a number, then you get its reciprocal. Now on to the examples of reciprocals. The reciprocal of 2 over 3 is 3 over 2 because I've flipped the fraction over. The reciprocal of 5 is 1 over 5 because I've done 1 divided by the number itself. The reciprocal of 1 over 9 is 9, and the reciprocal of x is 1 over x. We'll now move on to the non-examples. So, 0.2 is not the reciprocal of 4. We know this because 0.2 times 4 equals 0.8. And our definition is that when we multiply numbers together, it needs to equal 1 for it to be the reciprocal. The reciprocal of 2 over 3 is not 5 over 2 because 2 over 3 times 5 over 2 is 5 over 3. Because this is not 1, these are not the reciprocals of each other. And now on to today's questions. Question 1 is 2 over 3 times 5 over 8. To multiply fractions together, we multiply the numerators together and we multiply the denominators together. 2 times 5 is 10, 3 times 8 is 24. So 2 over 3 times 5 over 8 equals 10 over 24. We could simplify this fraction down. Both of these numbers can be divided by 2, so our fraction can simplify to 5 over 12. On to the second question, and it's very similar. We'll do 5 times 3 for the numerator, and 6 times 10 for the denominator. This gives us 15 over 60. Both of these numbers can be divided by 15, so our fraction can simplify all the way down to 1 over 4. If we look at question 3, we have 3 over 4 times 4 over 3. Notice the reciprocal of 3 over 4 is 4 over 3. It's the same fraction, but with the numbers swapped over. This means, from our definition of a reciprocal, that we automatically know that the answer is going to be 1. We can check this if we use the regular multiplying fraction method. Our numerator is 3 times 4, which is 12, The denominator is 4 times 3, which is 12, and 12 divided by 12 is 1. Question 4 has an integer multiplied by a fraction. To solve this calculation, we are going to write the integer as a fraction. 5 will be the same as 5 divided by 1. So we're going to multiply the numerators together to get 5 times 3, and the denominators together to get 1 times 4. 5 times 3 is 15, 1 times 4 is 4. So our final answer here is 15 over 4. Question 5 now includes algebra. Our regular method of multiplying the numerators together and multiplying the denominators together still works, but what we're going to do here, instead of writing 2c times 3, I'm going to write out 2 times c times 3. So when we get to simplifying, it's easier to see what happens. So for our numerator, we get 2 times c times 3. And for the denominator, we get 5 times 9 times c. When we want to cancel out here, if I have a variable on the numerator and the denominator, I can cross them out once each because they would cancel each other out perfectly. So here, I'm going to cross a c out on top and a c out on the bottom. And now I just need to multiply my numbers together. 2 times 3 is 6. 5 times 9 is 45. Both of those numbers can be divided by 3. This gives me 2 over 15 for the final answer. On to today's last question. We have 2ab over 5 times 3a over 10b. Again, I'm going to write each part of the numerator out explicitly. So I have 2 times a times b times 3 times a. And on the denominator, it will be 5 times 10 times b. I don't have an a in the denominator, so I cannot cancel out any of the a's in the numerator. I do have a b in the numerator and the denominator, so they can be cancelled out. So now I need to multiply my numerator together. I will do the numbers first, so 2 times 3 is equal to 6, and a times a is equal to a squared. And on the denominator, 5 times 10 is 50. We can simplify this further because both of the numbers, 6 and 50, can be divided by 2. So doing that, we get 3a squared over 25, and that is the final answer for 2ab over 5 times 3a over 10b. And that concludes today's lesson on fractions.